Good morning, students. Today our topic is differential equations, which is the 9th chapter in our CBSE book. The name of the chapter is Differential Equations. Differential equations. We are already familiar with equations. What we mean by equations is the combination of dependent variable and independent variable. For example, if we have y is equivalent to 2x plus 7, it is of course a linear equation in two variables in which y is dependent and x is independent variable. Thus, as per the subject matter of differential equations, it is an equation in which we have an involvement of differential coefficients. For example, dy by dx plus 7y plus 8 is equivalent to 0. It is a differential equation because it involves differential coefficients dy by dx. Similarly, another differential equation is dy by dx plus 13y plus 8 is equivalent to 0. This is another differential equation, and so on. We can find out an infinite number of differential equations. In this topic, we will find out how to evaluate differential equations. That means, given a differential equation, how can we find the actual curve involving this differential equation? For this, first of all, we need order of differential equation, order of differential equation, and degree of differential equation, degree of differential equation. What we mean by order of differential equation? It is the highest order derivative present in a differential equation. For example, d2y by dx square plus 3x dy by dx plus 8 is equivalent to 0. It is a differential equation of order 2 because the highest order derivative present in the differential equation is d2y by dx square, so its order is 2. Order is equivalent to 2. Similarly, dy by dx plus 3y is equivalent to 8 is a differential equation of order 1. That means, what is the order of a differential equation? It is the highest order differential coefficient present in the equation. Thus, to define order of a differential equation, first of all, differential equation an equation involving differential coefficients is called a differential equation. That is what is the differential equation. An equation involving differential coefficients is called a differential equation. Example, d2y by dx square plus 3 times dy by dx plus 13 is equivalent to 0. It is a differential equation. Similarly, d2y by dx square or d3y by dx cube plus sine inverse dy by dx plus 8 is equivalent to 0 is another differential equation. Now the order of a differential equation is the highest order derivative present in the equation. Example, dy by dx plus 8y is equivalent to 0 is a differential equation of order 1, because we have a differential coefficient here, it is of order 1. Similarly, second, d2y by dx square plus 3 times dy by dx plus 7 is equivalent to 0 is of order 2. Note that order of a differential equation is always a positive integer. That means we cannot say the order of the differential equation is in fraction, or the order of a differential equation is negative. Why? Because if we will say differential equation is of order 1 by 2 dx, we cannot find out what is the value of this d power 1 by 2 y by dx power 1 by 2. It is meaningless as per the differential equations are concerned. So we will confine ourselves that the order of a differential equation is always a positive integer. Another thing is degree of a differential equation. Degree of a differential equation. It is the exponent of highest order derivative present in a differential equation. That is, for example, sin x dy by dx plus twice d2y by dx square plus y is equivalent to 0. If it has 4 here, then we will see what is the order of this differential equation. First of all, order of this differential equation is 2. That means the highest order derivative present in the differential equation is 2. And its exponent is 4. So we will say degree is equivalent to 4. Another example, d2y by dx square plus dy by dx power 8 plus 3y is equivalent to 0. It seems to be it should have degree 8, but its degree is not 8 because we have to find the degree of the highest order derivative, that is 1. So we will see degree is equivalent to 1. And what about order? Order is 2. That means we have not to check which is the highest exponent in this differential equation, but we have to check the exponent of the highest order derivative present in the differential equation. Like we have so many examples in exercise 9.1. It is on page number 382. That is, determine order and degree if defined of a differential equation given in exercise 1 to 10. Exercise 9.1, question number 1. Determine order and degree if defined of the differential equation given in exercise 1 to 10. First is d4y upon dx power 4 plus sine y triple dash is equivalent to 0. Note that dy by dx can be also written as y dash, which can be written as y1. d2y by dx square is equivalent to y double dash, which can be written as y2, and similarly d3y by dx cube is equivalent to y triple dash, which is equivalent to y3, and similarly dn x raised power dxn is equivalent to yn. So here we have a differential coefficient of order 3, but with the help of the sign, it is actually the angle of sign, so it is not an equation. It is not an equation. Therefore, order is equivalent to 4, but degree not. Another question is question number 2. ds by dt power 4 plus 3s d2s by dt square is equivalent to 0. What is the highest order derivative? This. Its power is 1. So its order is 2 and degree is equivalent to 1. Similarly, in question number 3. In question number 2, we have y dash plus 5y is equivalent to 0. It has 1 dash, so order is equivalent to 2, order is equivalent to 1, and degree is equivalent to 1. Question number 4, that is d2y by dx square plus cos dy by dx is equivalent to 0. Here the involvement of angle cos dy by dx implies order 2, but degree not defined. Similarly, you can go through another questions. Say example of question number 9. Y double dash plus y dash square plus 2y is equivalent to 0. Here we have 2 dashes, so order is equivalent to 2, and degree is what here? 1. Degree is equivalent to 1. Question number 11, the degree of the differential equation, it is clearly, it involves angle, it involves the dy by dx in angle. So the option D is correct, that is, it is order is not defined, sorry, degree is not defined, while as question number 12 has the order of the differential equation. This question number 12, 2x square d2y by dx square minus 3 times dy by dx plus y is equivalent to 0. Clearly, we have the highest order derivative in this is this one, so order is equivalent to 2 and degree is equivalent to 1. Therefore, it is the order of the differential equation is 2. So option A is correct. Now, further we will go for the general and particular solutions of the differential equation. General and particular solutions of differential equations. What is the solution of the differential equation and what is general and particular solution? We will say in general solution we have arbitrary constants, and in particular solutions no arbitrary constants are present. Thus we will say an expression of the form, an equation of the form d2y by dx square plus if you have x plus y is equivalent to say A. It is a linear equation in two variables involving what? A constant. The values of x and y determine the value of A. So we will say it has one arbitrary constant. Similarly, x square plus y square is equivalent to r square is the equation of circle involving one arbitrary constant r, while as x square plus y square is equivalent to 1. It involves no arbitrary constant. So if a differential equation has solution of this form, we will say it is general solution, and this one is it is particular solution. That means if you have arbitrary constants, we can say it is the general solution of the differential equation, while as this is the particular solution. For example, if we have dy by dx plus x is equivalent to 0, A, we will say it implies dy by dx is equivalent to A minus x. We need to remove this arbitrary constant A by differentiating it. As many times as much we have the arbitrary constants, we will say d2y by dx square plus 1 is equivalent to 0 is the differential equation of this. Like in exercise 9.2, in each of 1 to 10, verify the given functions is a solution of the corresponding differential equation. Question number 1 is y is equivalent to e raised power x plus 1, and we need to check is y double dash minus y dash is equivalent to 0 a solution of this differential equation or not. We will say differentiate both sides with respect to x we get dy by dx is equivalent to e raised power x, and the differentiation of constant is 0, so it is equivalent to 0, which implies dy by dx is what? Y dash is equivalent to e raised power x. Again, differentiate with respect to x we get y double dash is equivalent to e raised power x, which implies y double dash is equivalent. What is e raised power x? E raised power x is y dash, which implies y double dash minus y dash is equivalent to 0. Yes, it is the solution of the differential equation. Similarly, question number 2, y is equivalent to x square plus 2x plus c, and we have to check is y double dash minus 2x minus 2 is equivalent to 0, the solution of the differential equation. This y double dash stands for we have to differentiate this equation 2 times. We will say differentiate with respect to x. With respect to x we get y dash is equivalent to derivative of x square is 2x plus derivative of 2x is 2. Y double dash, again differentiate with respect to x we get y double dash is equivalent to 2. Y double dash is equivalent to 2. Sorry, it was y dash minus 2x, single dash. So we need not to differentiate it 2 times. We will differentiate it just once. Y dash is equivalent to 2x plus 2, which implies y dash minus 2x minus 2 is equivalent to 0. Yes, it is a solution. Similarly, question number 3, we will go through question number 3 and I will show you question number 5. Y is equivalent to x, x y dash is equivalent to y for x not equivalent to 0. Differentiate with respect to x we get dy by dx, that is y dash is equivalent. A is a constant, it will come out, and the derivative of this x is equivalent to 1. So y dash is equivalent to a. Y dash is equivalent to a using in given equation, that is y is equivalent to, instead of a we will write a dash, y dash and x, which implies xy dash is equivalent to y. Yes, it is the solution of the differential equation. It is the solution of the differential equation. Next is question number 7. Question number 7, xy is equivalent to log y plus c. Y dash is equivalent to y square divided by 1 minus xy. Differentiate with respect to x. We will differentiate it just once. Why? Because we have only one dash, so we have to differentiate it just once. With respect to x we get It is of the UV form. dxy is equivalent to differentiation of log y plus dy by dx of a constant c, which implies by product rule x dy by dx plus y is equivalent. The derivative of log y is 1 by y dy by dx, and the derivative of constant is equivalent to 0, which implies x dy by dx minus 1 divided by y dy by dx is equivalent to this y will go there minus y. Let us take dy by dx common. Dy by dx x minus 1 by y is equivalent to minus y, which implies dy by dx. Let us write, instead of dy by dx we will write y dash into, by cross multiplication, y x xy minus 1 divided by y is equivalent to minus y. Which implies y dash is equivalent to minus y, and take the reciprocal of this, it is y upon xy minus 1, which is equivalent to minus times y square divided by xy minus 1, which is equivalent to y square divided by minus times xy minus 1. We have taken this negative sign to the denominator, which is equivalent to y square upon minus xy plus 1, which can be further written as y square upon 1 minus xy y dash, which is the required differential equation. Yes, it is a solution. Yes, it is a solution. Dear students, we will go through question number 11. The number of arbitrary constants in the general solution of a differential equation of fourth order. As much there are arbitrary constants, that will be the order of the differential equation. So, the number of arbitrary constants in general solution of differential equation of fourth order must be 4. The number of arbitrary constants in the particular solution of a differential equation of third order is, because it is the particular solution, and we know in general, particular solution we have no arbitrary constant, therefore question number 12 option is D, that is 0. Now we need to form, how to form differential equations. Formation of differential equations. Xy is equivalent to ax plus b. Suppose we have this equation and we need to find out it is differential equation. That means we have to emit the arbitrary constants a and b. We will differentiate both sides with respect to x. It will be x dy by dx plus y is equivalent to a, which implies xy dash plus y is equivalent to a. Further, we can use it in first we get xy is equivalent to, instead of a we will write xy dash plus y, and instead of a we will write a into x plus b. Xy is equivalent to xy dash plus xy plus b We have same quantity xy and xy on both sides. We can cancel it to get xy dash plus b is equivalent to 0. Again differentiate with respect to x, we get x times y double dash plus y dash into x is 1 plus 0 is equivalent to 0, which implies xy double dash plus y dash is equivalent to 0 is the required differential equation of the given equation. We have a few examples in exercise 9.3 in which we have to go to find out the differential equation of the curves by eliminating their arbitrary constants. Question number 1 in exercise 9.3, x divided by a plus y divided by b is equivalent to 1. We have here two arbitrary constants a and b, and we need to eliminate a and b. That means we have to eliminate this a and b without going on differentiating more than 2 times. That means we can at most differentiate this equation 2 times because we have two arbitrary constants. Differentiate with respect to x, we get 1 by a into derivative of x is 1 plus 1 by b, this is 1 by b dy by dx is equivalent to 0, which implies 1 by b dy by dx is equivalent to minus 1 by a. It implies dy by dx is equivalent to minus b by a, which implies y1 is equivalent to minus b by a. Again differentiating it with respect to x, so again differentiate with respect to x, we get y2 is equivalent to 0, which is the required differential equation, because y1, the derivative of y1 will be y2 and derivative of constant is equivalent to 0. It is the required differential equation of x divided by a plus y divided by b is equivalent to 1. Question number 2. Y square is equivalent to a into b square minus x square. We have here two arbitrary constants a and b. Differentiate both sides with respect to x, we get. Please note that we cannot differentiate it more than 2 times because we have two arbitrary constants in the given equation. We can at most differentiate it how much? 2 times. It will be 2y dy by dx is equivalent. A will remain as it is because it is a constant. It will come out from the derivative, and whatever differentiation of b square, it is equivalent to minus, it is equivalent to 0 minus, this will be 2x, which implies 2y and dy by dx is what? y1 is equivalent to minus 2ax. Again, or we can take like this, 2 and 2 cancel, y1 divided by x is equivalent to minus a, is equivalent to minus a. Again differentiate with respect to x, we have taken this a on right hand side because it is a constant, and on differentiating this constant it will emit. We have differentiation of this is u by v form, and x d by dx of y1 minus y1 d by dx of x whole divided by x square is equivalent to 0. Which implies x times, what is the derivative of y1? It will be y times derivative of this is y2 plus it is u into v form, y1 and derivative of y is again y1 minus y1 derivative of this is 1 divided by x square is equivalent to 0, which implies xy y2 plus xy 1 square minus y1 is equivalent to 0 into x square, which implies xy y2 plus xy1 square minus y1 is equivalent to 0 is the required differential equation of the given curve. Similarly, question number 3, y is equivalent to a e raised power 3x plus b e raised power minus 2x. We need to eliminate a and b here. We can say dy by dx, on differentiating it, dy by dx is equivalent to a e raised power 3x, because derivative of e raised power 3x is again e raised power 3x, and the differentiation of 3x is 3, plus b into e raised power minus 2x, and the derivative of minus 2x is minus 2, which is equivalent to 3a e raised power 3x minus 2b e raised power minus 2x. Again differentiate with respect to x, we get d2y by dx square is equivalent to 3a e raised power 3x, and the derivative of 3x is 3 minus 2b e raised power minus 2x, and the derivative of minus 2x is minus 2, which is equivalent to 3 3s are 9a e raised power 3x minus minus plus 4b e raised power minus 2x, which is equivalent to, or we can evaluate it further of that form. Multiply both sides by e raised power minus 2x plus 2x. To eliminate this, it will be e raised power 2x y is equivalent to a e raised power 3x into e raised power 2x plus b. Now this constant does not contain with itself the variable, so it will vanish on the differentiation. It will be e raised power 2xy is equivalent to a e raised power 5x plus b. Differentiate with respect to x, we get e raised power 2x, derivative of y is y1, plus y will remain as it is, derivative of e raised power 2x is e raised power 2x into 2, which is equivalent to a will remain as it is, e raised power 5x into derivative of 5x is 5, plus the derivative of b is 0, which implies e raised power 2x y1 plus 2y e raised power 2x is equivalent to 5a e raised power 5x. We will get rid from e raised power 5x from this arbitrary constant by multiplying both sides by e raised power minus 5x, we get e raised power 2x y1 into e raised power minus 5x plus 2y e raised power 2x e raised power minus 5x is equivalent to 5a e raised power 5x e raised power minus 5x. Which implies y1 e raised power 2x minus 5x plus 2y e raised power 2x minus 5x is equivalent to 5a e raised power 5x minus 5x, which implies y1 e raised power minus 3x plus 2y e raised power minus 3x is equivalent to 5a. On differentiating this curve, this is independent of the variable, so it will vanish. Differentiate both sides with respect to x, we get y1 e raised power minus 3x and derivative of minus 3x is minus 3 plus, now e raised power minus 3x will remain as it is, derivative of y1 is y2 plus 2 times derivative of y is y1 and e raised power minus 3x will remain as it is plus derivative of e raised power minus 3x is e raised power minus 3x into minus 3 is equivalent to derivative of 5a is 0, which implies minus 3y1 e raised power minus 3x plus y2 e raised power minus 3x plus 2y1 e raised power minus 3x minus 3 2s are 6 y e raised power minus 3x is equivalent to 0. We will take e raised power minus 3x common. E raised power minus 3x, this will be 3y1 plus y2 plus 2y1 minus 6y is equivalent to 0. Which implies e raised power minus 3x, 3y1 and 2y1 is 5y1 plus y2 minus 6y is equivalent to 0. But e raised power minus 3x cannot be equivalent to 0. Therefore, we will see y2 plus 5y1 minus 6y is equivalent to 0 is the required differential equation of the given curve. Another example is you will go through question number 4 and question number 5, which is homework for you. We will go for question number 6. Form the differential equation of the family of the circles touching y-axis at origin. First of all, we will recall the general equation of a circle. Suppose this is a circle with center at h comma k and radius r. That means this distance is k and this is h and the radius of the circle is r. Then its equation is x minus h square plus y minus k square is equivalent to r square, which we have already studied in what? 11th class. It is a circle whose center is at h comma k and radius is r square. Now, in question number 6, we have form the differential equation of the family of circles touching y-axis at origin. That means you have a circle which touches y-axis at origin. It can be this type of circle or another circle of this form. Clearly its center will be at x-axis and this distance is r. So it is coordinates of the center are r comma 0. And we know the general equation of the circle. We know that the equation of a circle is x minus h square plus y minus k square is equivalent to r square, where c h comma k is center and r is radius. But here h is equivalent to r, k is equivalent to 0 and r is equivalent to r. Therefore equation of circle reduces to what? X minus instead of h we have r, x minus r square plus y minus instead of k we have 0, y minus 0 square is equivalent to r square, which implies x minus r whole square plus y square is equivalent to r square. We can expand this by binomial expansion as x square plus r square minus twice xr plus y square is equivalent to r square. Same quantities, it will cancel out. X square plus y square is equivalent to twice xr. We can say it implies x square plus y square divided by x is equivalent to 2r, which implies x plus y square divided by x is equivalent to twice r. Differentiating with respect to x, differentiate both sides with respect to x, we get differentiation of x is 1 plus it is u by v form times derivative of this is 2y y dash minus y square into derivative of x is 1 divided by x square is equivalent to the derivative of constant is 0, which implies twice x y y dash minus y dash minus y square is equivalent to this one minus 1 into this one x square, which implies twice x y y dash minus y square is equivalent plus x square is equivalent to 0. We can further say twice x y y dash plus x square minus y square is equivalent to 0 is the required differential equation of the given circle. Question number 7 is, form the differential equation of the family of parabolas having vertex at origin and axis along y-axis. We know that we have 4 types of parabolas, that is y square is equal to 4ax, y square is equal to minus 4ax, x square is equal to 4ay and x square is equal to minus 4ay. Here in question number 7 of parabolas having vertex at origin, vertex is at this point and axis along y-axis, that means it is an upper parabola, and we know the equation of upper parabola is the equation of parabola is x square is equal to 4ay, where focus is at this point 0 comma a. We have here one arbitrary constant which implies x square divided by y is equal to 4a. Differentiate both sides with respect to x, we get it is u by v form. Y times differentiation of x square is 2x plus x square, sorry, minus x square, and differentiation of y is y1 divided by y square is equal to 0, which implies twice xy minus x square y1 is equal to 0, or x square y1 minus twice xy is equal to 0 is the differential equation of this type of parabola. Similarly, dear students, you will go through question number 8 and 9, and the question number 10 is form the differential equation of the family of circles having center on y-axis and radius 3 units. Question number 10. Form the differential equation of the family of circles having center on y-axis. That type of circle which has center at family of circles having center on y-axis and radius 3 units. Here radius is 3 and the coordinate of this is 0 comma say a 0 comma k. We will say the general equation of circle is x minus h square plus y minus k square is equivalent to r square. Here radius is 3 units, so we will say r is 3. Here h is equivalent to 0, k is equivalent to k, but r is equivalent to 3. Therefore, x minus 0 square plus y minus k square is equivalent to r square is 3 square, which implies x square plus y minus k square is equivalent to 9, which implies y minus k whole square is equivalent to 9 minus x square. We can further say it implies y minus k is equivalent to 9 minus x square power 1 by 2. Differentiate both sides with respect to x, we get y1 and derivative of k is 0 is equivalent to power down power minus 1 by 2 minus 1, and the internal derivative of this, that is minus 2x, which implies y1 is equivalent to 2 and 2 cancel, minus x divided by 9 minus x square, 9 minus x square power 1 by 2, which implies 9 minus x square power 1 by 2 y1 is equivalent to minus x squaring both sides, 9 minus x square into y1 square is equivalent to x square, which implies 9y1 square minus x square y1 square is equivalent to x square is the required differential equation of such a circle. You will go through question number 11 and 12. It is a multiple choice questions. Now we will go for methods of solving differential equation of first order and first degree. First method is called a variable separable. By saying the solution of the differential equation, we mean given a differential equation, we have to say what is the curve corresponding to this differential equation. First of all, we have variable separable. That means in this method, we will separate the variables. For example, if you have dy by dx is equivalent to f of x comma y, a function of x comma y, and this function of x comma y can be factorized by saying it is equivalent to g of x and t of y. Then we will say dy upon ty, a function of y from this is equivalent to dx gx dy by dx. That means this gx and dx will be from one side and dy and ty on the another side. So on the left hand side we have just y's and on the right hand side we have just x's. Further we can integrate it. It will be integral dy upon ty is equivalent to integral gx dx, and the integrals can be evaluated as we have done already in integral calculus. For example, in exercise 9.4, question number 1, dy by dx is equivalent to 1 minus cos y divided by 1 plus cos y. Sorry, 1 plus cos x, 1 minus cos x and 1 plus cos x. This is question number 1 of exercise 9.4. It is easy to separate the variables by multiplying dx on right hand side. Dy is equivalent to 1 minus cos x divided by 1 plus cos x dx. And we know that cos of twice theta is equivalent to twice cos square theta minus 1. It is equivalent to 1 minus 2i sin square theta, or it can be written as cos square theta minus sin square theta. We will make use of these two formulas by saying that this one will come towards the left, 1 plus cos 2 theta is equivalent to twice cos square theta, and 1 this will come towards the right, and this from the left it will be 1 minus cos 2 theta is equivalent to twice sin square theta. But we have not 2x here, so we will write it is 2 times x by 2. It is 1 minus cos of 2 times x by 2 divided by 1 plus cos of 2 times x by 2 dx, which is equivalent to 1 minus is twice sin square x by 2 divided by twice cos square x by 2 dx. 2 and 2 will cancel out. It will be sin square divided by cos square, that is tan square x by 2 dx. It is dy. Integrate integral dy is equivalent to integration of tan square x by 2 dx. And we do not know what is the integration of tan square, but we can use an identity, and the identity is known to be sec square theta minus tan square theta is equivalent to 1. It implies integral dy is equivalent to integration of tan square is sec square theta minus 1. That means sec square x by 2 minus 1, which is equivalent to integration of sec square x by 2 dx minus integration of dx. It is integral of dy. Integration of dy is y is equivalent to integration of sec square theta. It is tan x by 2 divided by derivative of x by 2, that is 1 by 2, minus integration of dx is x plus c, which implies y is equivalent to twice tan x by 2 minus x plus c is the required equation whose differential equation was given. Similarly, question number 2, say question number 3. Question number 3, dy upon dx plus y is equivalent to 1 plus y is equivalent to 1. We need to separate the variables. First of all, take all the terms towards the right instead of the differential coefficient. Dy by dx is 1 minus y. We will see it implies dy upon 1 minus y, and we have no x's here, so it is 1 times dx. Integrate integral dy upon 1 minus y is equivalent to integration of dx, which implies, I will put here a minus because derivative of this thing is minus times dy, and a minus out, it will be minus times log of 1 minus y is equivalent to x plus c, or we can say it implies x plus log of 1 minus y plus c is equivalent to 0 is the corresponding equation, is the equation corresponding to this differential equation. Similarly, question number question number 4, that is sec square x tan y dx plus sec square y tan x and dy is equivalent to 0. First of all, we will take dx at one side and dy on the another. Sec square x tan y dx is equivalent to minus times sec square y tan x and dy. All the variables, all the terms containing x will be from the left, and all the terms which contain y will be on dy side, which implies sec square x and tan y will go towards the right dx, and instead of that tan x will come towards the left. Tan x is equivalent minus sec square y divided by tan of y, and it will be dy here. Integrate integral of sec square x dx divided by tan x is equivalent to minus times integral sec square y divided by tan y and dy. The derivative of tan x is sec square x. So the denominator has derivative as numerator. We can say it implies log of tan x is equivalent to minus times log of tan y, because the derivative of tan y is sec square y dy plus c, which implies log of tan x plus log of tan y is equivalent to c. And we know that log m plus log n is equivalent to log of m divided by n. So it is log of tan x divided by tan y modulus is equivalent to c. Which implies tan of x divided by tan of y is equivalent to, if we will take log from this will be e raised power c, which is another constant, say tan x divided by tan y is equivalent to a bigger c, say capital C, which implies tan x is equivalent to c times tan y is the required equation corresponding to the given differential equation. Our question number 5 is e raised power x plus e raised power minus x dy minus e raised power x minus e raised power minus x dx is equivalent to 0. We will take dy on the left hand and dx on the right hand side. It implies e raised power x plus e raised power minus x dy is equivalent to e raised power x minus e raised power minus x dx. We have variable x towards the left, so we will take it on the right hand side. It will be equivalent to dy e raised power x minus e raised power minus x dx upon e raised power x plus e raised power minus x. Now integrate, because we have taken the variables x on one side and variable y on the another, we can integrate it. Integral dy is equivalent to integral e raised power x minus e raised power minus x upon e raised power x plus e raised power minus x dx, which implies y is equivalent to derivative of the denominator. E raised power x has derivative e raised power x, and plus e raised power minus x has minus times e raised power minus x. So the derivative of the denominator is numerator. Therefore we will see it is log of the denominator, e raised power x plus e raised power minus x plus c. This is the required equation corresponding to the given differential equation. You will go through other questions. Let me show you another question, which is question number 11. It is find the differential equations and find it is a particular solution satisfying the given condition. Question number 11. X cube plus x square plus x plus 1 dy by dx is equivalent to twice x square plus x, given that y is equivalent to 1 when x is 0. These values of x and y will make the general solution, which contains the arbitrary constants, a particular one. We will first find the equation. It will be x cube from x cube plus x square. Let us take it on the right hand side. Dy is equivalent to twice x square plus x divided by x cube plus x square plus x plus 1 and dx, which implies dy is equivalent to, we will integrate it, integral dy is equivalent to integral 2x square plus x divided by x cube plus x square plus x plus 1 dx, which is equivalent to, it implies integral of dy is y, integral, let us take 2x square plus x divided by, take x square common from these two, it will be x square into x plus 1 plus 1 into x plus 1 dx, which is equivalent to 2x square plus x divided by x plus 1 into x square plus 1 dx, which can be further solved by using partial factors, as it is integral a divided by x plus 1 plus bx plus c divided by x square plus 1 dx. Which imply where 2x square plus x divided by x plus 1 into x square plus 1 is equivalent to a divided by x plus 1 plus b x plus c divided by x square plus 1 taking the cross multiplication, it will be a times x square plus 1 plus bx plus c into x plus 1 divided by x plus 1 into x square plus 1, and on the left hand it is 2x square plus x divided by x plus 1 x square plus 1. This and this will cancel out. Which implies twice x square plus x is equivalent to ax square plus a plus bx into x is bx square plus bx into 1 is bx plus cx plus c. or you can use everywhere not there formula, which implies 2x square plus x is equivalent to take ax square and bx square, a plus bx square plus the terms containing x are b and c, b plus c, x, and the constant term is a plus c. Comparing coefficients, we get a plus b is the coefficient of x square, and here we have coefficient of x square 2, so a plus b is equivalent to 2. Here b plus c is the coefficient of x, and here we have coefficient of x as 1, so b plus c is equivalent to 1. And constant term is on the left hand side, it is 0, so on the right hand side a plus c must be equivalent to 0, which implies a is equivalent to minus times c. Or we can use elimination method. In these two, we will write a plus c is equivalent to 0, and it will be minus minus, and minus b minus a is equivalent to 1. Which implies a minus b is actually minus 1, but a plus b is 2. A plus b is equivalent to 2. B and b cancel out. 2a is equivalent to 2 minus 1, that is 1. So a is equivalent to 1 by 2. Using in this, a plus c was what? 0, which implies c is equivalent to minus times a, which implies c is equivalent to minus times 1 by 2. Now b plus c is 1, b plus c is equivalent to 1, which implies b is equivalent to 1 minus c, which is equivalent to 1 minus c is what? Minus 1 by 2. So it is equivalent to 1 plus 1 by 2, which is equivalent to 3 by 2. Thus we have obtained the values of a, b and c, which we can use in this. Y is equivalent to integral a divided by, instead of a we have 1 by 2 divided by x plus 1 plus bx, instead of b we have 3 by 2 x plus c is equivalent to minus 1 by 2 divided by x square plus 1, and we have dx. Now we need not this equation. Y is equivalent to 1 divided by 2 integral dx divided by x plus 1 plus 1 by 2 3x minus 1 divided by x square plus 1 dx, which is further equivalent to 1 divided by 2 log of modulus x plus 1, because integration of dx divided by x plus 1 is log of x plus 1, plus 1 by 2 integral 3x divided by x square plus 1 minus 1 divided by x square plus 1 and dx, which is equivalent to 1 divided by 2 log of modulus x plus 1 plus 1 divided by 2, take this 3 out, it is x divided by x square plus 1 dx minus 1 divided by 2 integral dx divided by x square plus 1, which is equivalent to 1 divided by 2 log of modulus x plus 1 plus, I will say 3 by 4 because I need 2 here, so that the numerator will be derivative of the denominator. So I will use 3 by 2 into 1 by 2 So this 2 I will use over here. 2x divided by x square plus 1 dx minus 1 divided by 2 integral dx divided by x square plus 1, which is equivalent to 1 divided by 2 log of modulus x plus 1 plus 3 by 4 log of x square plus 1 minus 1 divided by 2. This is x square plus 1 square, which is equivalent to tan inverse x by 8 plus c which implies y is equivalent to 1 divided by 2 log of modulus x plus 1 plus 3 divided by 4 log of x square plus 1 minus 1 divided by 2 tan of x plus c. But y is equivalent to 1 when x is equivalent to 0. It was the given condition. Y is equivalent to 1 when x is 0. Put y equivalent to 0 and x is equivalent to 1 throughout the equation. Y will be equivalent, sorry, y is equivalent to 0, y is equivalent to 1 is equivalent to half of log modulus of x plus 1. That means modulus of 0 plus 1, that is 1, plus 3 upon 4 log of x is 0, so it is again 1, minus 1 divided by 2 tan inverse x, that is 0, plus c. 1 is equivalent to log of 1 is equivalent to 0, plus 3 by 4 log of 1 is again 0, minus tan inverse 0 is 0 plus c, so c is equivalent to 1. This is the c, arbitrary constant c is equivalent to 1. Using in this equation, let us name it star. Using c is equivalent to 1 in star, we get y is equivalent to 1 divided by 2 log of modulus x plus 1 plus 3 divided by 4 log of x square plus 1 plus, sorry, minus 1 divided by 2 tan inverse x plus, instead of c we have 1, which is the required particular solution of the given differential equation. Hope you will go through other questions. I will show a problem type question, which is question number 17. Find the equation of curve passing through the point 0, minus 2, given that any point on the curve, the product of the slope of its tangent and y coordinate of the point is equivalent to the x coordinate of the point. Question number 17, that is find the equation of the curve passing through point 0, 2. A curve passes through 0, minus 2. This is the given condition. Given that at any point x, y, the product of the slope of its tangent, that we know that the slope of the tangent, is given to be dy by dx, and given that at any point on the curve, according to condition, the product of the slope, that means dy by dx, into y coordinate, that means y, is equivalent to the x coordinate at that point, means x, which implies y times dy must be equivalent to this. Dx will go towards the right, x dx, integral y dy is equivalent to integral x dx, and integration of y is y square by 2 is equivalent to x square divided by 2 plus c, which implies y square is equivalent to x square plus 2ic on multiplying by c by 2. But curve passes this very point 0 comma minus 2. So every curve, when it passes through a point, it satisfies the curve. We will see it implies instead of y we have minus 2. So minus 2 square should be equivalent to, instead of x we have 0. So 0 square plus 2ic. So 4 is equivalent to ic, which implies c is equivalent to 2. Using in star, let us name this equation as star. Using in star, y square is equivalent to x square plus 2ic 2 into 2, which implies y square is equivalent to x square plus 4 is the required curve. Now students, we have completed variable separable. Now the next topic is homogeneous. Homogeneous differential equations. First of all, what we mean by homogeneous differential equation? We will say an equation of the form f of x comma y, lambda x comma lambda y is equivalent to lambda raised power n f of x comma y is said to be a homogeneous of degree n if it can be written in this form. For example, f of x comma y is equivalent to x square plus xy. If we will put x is equivalent to vx and y is equivalent to vy, we will obtain f of lambda x comma lambda y is equivalent to, instead of x we have vx square, plus instead of x we have x, but instead of y we have, sorry, this is vx and this is vy. We will say it is v square x square plus v square xy, which is equivalent to, sorry, it is a lambda here. Let us put lambda and this is over here lambda. So lambda times lambda square and this 2 is lambda. Take lambda square common, it is x square plus y square. So we can say it is lambda square f of x comma y. So it is a homogeneous of degree 2. Similarly, if we have f of x comma y is equivalent to x plus y, we can say f of lambda x plus lambda y is equivalent to what? Lambda x plus lambda y. Take lambda common, it is x plus y, but x plus y is equivalent to what? F of x comma y. So it is lambda times f of x comma y, x plus, this is x comma y. Here we have the power of lambda as 1, so it is a homogeneous of degree 1. We will confine today ourselves with a homogeneous of degree 0, that is of this form, like example third, if we have f of x comma y like x square plus xy divided by xy twice plus thrice x square, if f of lambda x comma lambda y will be equivalent to, it is lambda x square plus lambda x and lambda y upon twice lambda x lambda y plus thrice lambda x square, which is equivalent to lambda square x square plus lambda square xy upon 2 times lambda square xy plus thrice lambda square x square. Take lambda common in the numerator as well as in denominator. It will be lambda square x square plus y square upon lambda square into twice xy plus 3x square. Look at this. This and this will cancel out. It is equivalent x square plus y square divided by twice xy plus thrice x square, which is equivalent f of x comma y. So I can say it is lambda raised for 0 here. That means it is a homogeneous of degree 0. We will confine today on homogeneous of degree 0. If we have a homogeneous, to solve a homogeneous, we will follow a certain rule, like you have dy by dx is equivalent to f of x comma y. If we have this form of an equation, we will make it f of y upon x. We will make it a function of y upon x type. Then we will make a substitution, put y is equivalent to vx, such that dy by dx will be equivalent to v will remain as it is, the derivative of x is 1, plus x will remain as it is, differentiation of v is dv by dx. So it is equivalent to v plus x dv by dx. Then instead of dy by dx, we will say it is v plus x dv by dx is equivalent to, in this f of y upon x, y stands for vx upon x, this and this will cancel out, so x dv upon dx. See, let us name it, it is not the function f, let us name it g, so it is over here g, so it is equivalent to g of v minus v. Then we will use the already done method called variable separable, dv upon this gv minus v, gv minus v is equivalent to dx, this dx upon x, and then we will integrate as we have already done in variable separable. Then we will integrate this and find the integrate of this left hand side as well as right hand side, which will be this solution of the differential equation. Like exercise another type is if we have not this dy by dx form, we can have another form as dx by dy, and which is, say, f of f1 of x comma y. Let us name it, it is equivalent to g of, and it is of the form y. We will not make y is equivalent to vx substitution, but we will make x is equivalent to vy and follow the same pattern, same rule as done in this. The complete solution will be obtained in this case also, like in question number 1 of exercise 9.5. It is on page number 406. In each of the following 1 to 10, show that the given differential equation is homogeneous and solve them. Question number 1, exercise 9.5, question number 1. We have x square plus xy into dy is equivalent to x square plus y square into dx. Now look at this. we can say it implies dy by dx is equivalent to, we have taken this as denominator and this will be the denominator on right hand side, x square plus y square divided by x square plus xy. We have to show first what this is a homogeneous differential, homogeneous. We will say here, what is f of x comma y? F of x comma y is equivalent to x square plus y square upon x square plus xy. Replace x by lambda x and y by lambda y. It will be f of lambda x comma lambda y is equivalent to lambda x square plus lambda y square divided by lambda x square plus lambda y square, which is equivalent to lambda square x square plus lambda square y square upon lambda square x square plus lambda square y square. Take lambda square common in numerator as well as denominator. It will be lambda square x square plus y square upon lambda square x square plus, this is x square here, this is lambda x lambda y, lambda x lambda y, and this will be lambda square will come out, it will be xy. This and this will cancel out, so it is f of x comma y, and this f of x comma y can be written as lambda is for 0, f of x comma y. So it is a homogeneous of degree 0. Therefore, the same method is applicable here. We will say it is a homogeneous. So put what substitution we will make here? Yes, y is equivalent to Vx, such that what is dy by dx? Dy by dx will be equivalent to V. V will remain and x, we will differentiate x. It is 1 plus x times differentiation of V is dV by dx. So in this, therefore, dy by dx, instead of dy by dx we will write V plus x dV by dx is equivalent to x square is x square, but what about y? Y is Vx, so it is Vx square divided by x square will remain plus x, and instead of y we will make Vx, which is equivalent to, take x square common in the numerator, it will be 1 plus V square upon x square common in the denominator, it will be 1 plus V. X square and x square will cancel out. So x dV by dx, take this V on the right hand side, this is positive here, this will go negative on the right hand side, 1 plus V square upon 1 plus V minus V upon 1. Then x dV by dx is equivalent, take cross multiplication, it will be 1 plus V square into 1 minus V into 1 is V plus minus V square upon 1 plus V into V, 1 is 1 plus V square and V square will cancel out, it is 1 minus V upon 1 plus V. What is this? X dV by dx. Now we can separate the variables because we have V's on the V's as one factor and X is as another factor. We will say it implies dV will remain and this denominator will be numerator for the left hand and this will be as denominator of the left hand is equivalent. This dx will go there and it will be dx upon this will be a denominator x. Now we can integrate it. it will be integral 1 plus v upon 1 minus v dv is equivalent to integral of dx by x, which implies integral 1 upon 1 minus v plus v upon 1 minus v. Why? It is 1 upon 1 minus v plus v upon 1 minus v, and dv is equivalent to, what is integration of dx by x? It is log of x. Let us see, constant of integration is c, which implies, what about derivative of this? It is derivative is what? It is minus 1. We will say it is minus over here, then we will put minus here. And what about this? It will be minus times log of 1 minus v plus. Look at this. When the degree of numerator and denominator will be same, we will say it is let us go for another step here. It implies minus times log of 1 minus v plus what? Integration of this. It will be, say, minus times. If we will take minus times, it will be v upon, this is 1 minus v. We have taken minus common, so it will be v minus 1. v minus 1 dv is equivalent to log x plus c. Which implies minus times log of 1 minus v minus. Look at this. It is v minus 1 and the numerator is v. You can divide it. v minus 1. See, divide v 1 the v minus 1. This will be minus, this will be plus. It will be 1. 1 will come as remainder. We can say it is 1 plus 1 upon v minus 1. Look at this. If we will multiply it, v minus 1 minus 1 plus 1 will cancel out. It will be v divided by v minus 1, and dv is equivalent to log of x plus c, which implies minus times log of 1 minus v minus integration of 1 is v, and minus integration of 1 by v minus 1 is log of modulus v minus 1 is equivalent to log of x, put it in modulus, plus c, because log of the negative is not defined, plus c. Then it implies, take minus common, it will be log of 1 minus v plus log of v minus 1, and then this minus will come out as plus log of x, and take this v on the right hand side, it will be v plus c, which implies minus times. We know log of m plus log of n plus log of t is equivalent to log of m and t. Log of 1 minus v into v minus 1 into x is equivalent to v plus c, which implies log of, it is modulus here, it will be log of 1 minus v square into x is equivalent to minus times v plus c, which implies, but we know we have made a substitution, y is equivalent to vx, which implies v is actually what? Y upon x. V is actually y upon x. Make the substitution, log of modulus 1 minus v square is y square by x square into this very x is equivalent to minus v is what? Y upon x plus c. We can further solve it by multiplying x and take log on the right hand side, it will be exponential, so to match the required solution. Then we have question number 2. Question number 2 is y dash is equivalent to x plus y divided by y dash is equivalent to x plus y divided by x. This is question number 2. Y dash stands for what? Dy by dx is equivalent to x plus y divided by x. I hope you will show this is a homogeneous by proceeding in the similar way as done in above this example, above question. So I will say it is a homogeneous. It is a homogeneous. Therefore, I will make the substitution what? Y is equivalent to Vx such that what is dy by dx? It is V plus x dV by dx. Make the substitution in this. Instead of dy by dx, we will write what? V plus x dV by dx is equivalent to what? X. X is what? Vx. Sorry, it is x plus instead of y we have Vx divided by x. Take x common in numerator. It will be x times 1 plus V divided by x. Cancel this x and x. It will be 1 plus V. But what is 1 plus V? It is V plus x dV by dx. Same quantities V and V are on both sides. We can cancel it. So x dV by dx is equivalent to 1. Further, now we can separate the variables. It implies dV will be equivalent to this dx will go as numerator and this x as denominator and integrate. Integral of what? dV is equivalent to integral of dx by x. What is integration of dV? It is V is equivalent to what about integration of dx by x? It is equivalent to log of x plus c. But we made the substitution what? Y is equivalent to Vx. Therefore, we will see V is y upon x because we have to reduce it in the same variables as are given in the question. So it is y upon x is equivalent to log x plus c. We can further say y is equivalent to x log x plus cx is the required solution.